I welcome you all to the session of engine system and performance, and today we shall discuss about the methods of calculating injection duration time. So, if we try to recall, in our last class we had discussed about electronic fuel injection system, and we had seen from our previous discussion that the injection duration is very important, essentially from the perspective of fuel economy and engine efficiency. Most importantly, if we can design proper pulse width and also the frequency of pulses, certainly engine efficiency will increase. Over and above, emission level can be controlled. So, today we shall discuss a few aspects, rather method of the calculation for injection pulse width, or to be precise, injection duration calculation. So, injection duration calculation is basically a two-step process, and two different steps are basic injection duration calculation and the second one is injection calculation correction factors. So, if we write that injection duration calculation, this is basically a two-step process. And if it is a two-step process, then what are these two steps? First one, or I should write, yes, first one, that is basic injection duration, that is basic injection duration calculation or calculation of basic injection duration. 2 is injection duration correction factors. So, you can understand we need to have proper or optimum injection duration. Essentially, fuel injection, electronic fuel injection system is a part of electronic control system, and ECU will give some signal to the driver unit to operate injectors to have proper duration. And as I said, proper calculation of injection duration, that is the duration of or time duration of fuel injection, is very important to bring fuel economy as well as to reduce emission. So, this is involved with two different processes. The first is basic injection duration calculation, that means we have to first calculate the basic injection duration, then after determining the basic injection duration we can go for some corrections over this step, essentially to match the required injection duration or required duration to run the engine, not always at optimum condition, but closer to the optimum condition. So, this is these are two different steps. Now, if we now elaborate on the first step, so if we go to the next slide, that is basic injection duration calculation. So, this this particular step basic injection duration is reliant on a few input sensors, right. So, there are ECU or electronic control unit is reliant on a few input signals, those will be received from different sensors. The basic injection duration is reliant on a few input sensors, and these input sensors are, number one is certainly engine speed, second one is airflow meter, and then very important is that manifold absolute pressure. This is also very important. So, these three sensors are very important for the calculation of basic injection duration. Electronic control unit, as I said you, determines basic injection duration based on engine RPM and airflow volume, right. So, that means the amount of air is drawn into the engine cylinder during intake stroke together with what is the speed of the engine. These two parameters are this, rather I should say these two particular quantities, these two quantities are very important. So, let me repeat once again, basic injection duration calculation is based on the engine speed and airflow volume. So, airflow meter sensor will give some input to the ECU about the mass of air is drawn into the engine cylinder. Similarly, engine speed sensor will give some input to the ECU, the speed at which engine is running. Based on these two input parameters or based on these two quantities will be received by the ECU from these two sensor, basic injection duration is calculated. To be precise, these two parameters or these two quantities, rather not parameters, engine speed and airflow volume, these two quantities are regarded as the engine load factor. And so, just write, I am writing. So, engine speed and airflow volume are the engine load factors. Okay. These two quantities are regarded. Now, question is, if any of these two parameters, or I should say as either of these parameters increase, basic injection duration is increased. Quite obvious, that if engine speed increases, certainly fuel that needs to be supplied to the cylinder should increase. Similarly, to meet the load of the engine, if we need to develop, or if the engine needs to develop more power, if we need to extract more power from the engine, airflow volume should be more. If airflow volume or more amount of air is drawn into the engine cylinder, to burn that, assuming that the ratio is always stoichiometric, more amount of fuel should be supplied. So, these two parameters are very important, and as either of these parameters increase, injection duration is increased. It is important to mention here that electronic control unit cannot operate if any one of these two quantities is faulty. That means, electronic control unit has to receive proper input from engine speed sensor and intake airflow meter sensor. So, that is the air mass of air or volume of air drawn into the engine cylinder. Okay. So, now let me tell you one thing, by how it is possible for an injector or for the ECU to give some input to the driver circuit of injector to provide or to open. Essentially, you have studied in internal combustion engine course that fuel injectors, there is a needle and that needle has to lift, or that will be pulled by the injector to open the gap, and through that gap fuel should be injected into the engine cylinder. Now, the question is how much that needle would be raised, or that lift of the needle from the sitting place. Needle is always spring loaded. So, it will always, the normal tendency of the needle is to remain seated over there, but if we have some mechanism to lift the needle from its initial position, we can have some opening area. Through that opening area, a certain amount of fuel or metered quantity of fuel should be injected, right. So, that injector control unit should be capable of giving some forcing to lift the needle, and that would be again controlled by the electronic control unit. So, let us now discuss about the procedure of functioning a particular injector or injector to calculate basic injection duration. So, you know what is done, basic injection output signal is derived from a stored characteristic map. See, this map is stored in the on the chip of ECU, So, basically this characteristics map forms a part of read only memory that you have studied, read only memory chip in the ECU. So, let me tell you once again, this characteristic map forms a part of read only memory chip in the ECU. So, this map is already stored. So, we have to have this map. Now, in this map essentially, if I just try to describe here, this map is prepared. So, this is the characteristics map. So, there are that this is throttle opening. So, this is throttle opening angle TOA, and this is engine speed. Now, this map is prepared based on some data, and these data, so basically this TOA stands for throttle opening angle, and ES, that is engine speed. Okay. So, typically what is done, TOA 15 throttle opening angles are considered to develop this map, and 15 engine speed. So, we consider 15 data for throttle opening angle and 15 data for engine speed. So, what is throttle opening? So, different angles. Throttle opening indicates you have studied in your basic or internal combustion engine course, full throttle opening, throttle is fully closed, throttle is fully open. That means this is very important that how far the throttle is open. So, this is essentially the indication of throttle opening angle, how far the throttle throttle valve is open, throttle valve rather. Similarly, we can have 15 engine speed. So, you can see we can have 15 cross 15, that is 225 data points. To prepare this table, this table is prepared based on these 225 data points, right, and these 225 data points. So, for a given throttle opening angle for a given speed, this table is prepared, and this table is prepared based on the output from extensive engine trials, and this extensive engine trials is conducted extensive engine trials is conducted at a stoichiometric air fuel ratio. So, using a stoichiometric air fuel ratio, but considering a stoichiometric air fuel ratio, if we perform engine test, and based on the engine test, if we can figure out if the throttle opening angle is 15 degree, then what should be the speed. Following this, we can have these 225 data points, and having this table is stored in the ECU, and this table, as I said you, it forms a part of read only memory in the ECU, right. Now, the question is to speed the, so this is essentially a lookup table, right. So, this is a lookup table. Okay. So, to increase the lookup table, to increase the speed of the lookup table, no interpolation is allowed. So, I can write here. So, to increase the speed of the lookup table, no interpolation is done. That means, had we conducted test considering stoichiometric air fuel ratio, then if we could measure engine speed, say for example at 15 degree throttle opening and then also 20 degree throttle opening, no interpolation is allowed in this lookup table to know the engine speed in between these two throttle opening angles, that is 15 degree and 20 degree. So, this is essentially done essentially to increase the speed of the lookup table. Okay. So, now the question is, if that is the case, then there can be a deviation in this lookup table, then what remedial action is or step is taken. So, that means, if there is a deviation from this lookup table, then what remedial measure is taken by the ECU to operate injectors, if it is a multi-cylinder engine, of course. So, now question is, to do that, right, an adaptive map with 8 into 8 data points is built onto the basic characteristic map. Now, if there is any deviation, so no interpolation is allowed essentially to increase the speed of the lookup table, but if there is any deviation, so let me write again here. So, if a given deviation on the basic map is exceeded. So, if a given deviation on the basic characteristic map is exceeded, an adaptive algorithm installs correctional values onto the adaptive map, right. So, this is very important. First of all, what we have discussed, that this characteristic map is prepared based on 225 data points, and these 225 data points are obtained from extensive engine trials considering stoichiometric air fuel ratio, and to increase the speed of the lookup table, no interpolation is allowed. So, if there is a deviation, then what remedial measures should be taken by the ECU to operate injector. So, to do that, what is done, if a given deviation on the basic map is exceeded, an adaptive algorithm installs correctional values onto the adaptive map. So, now this adaptive algorithm, which is based on some evaluation of signals received from a special sensor, and that is known as lambda sensor. So, a special sensor should be integrated to that circuit, and that sensor is responsible to provide some signal or input. Based on that input, this adaptive algorithm will do some corrections, and those correctional values are mapped onto this adaptive table, and that adaptive table is built onto this basic table. So, this way some remedial or some preventive measure is taken to increase the sensitivity or efficacy of the control unit, so as to allow injector to operate even there is any deviation. So, this is the first step, and as I said you that this particular basic map is basic map forms a part of read only memory in the ECU. Then second point is that we have discussed, or second step is injection duration corrections, duration correction factor. So, injection duration correction factors. So, try to understand, having establish the basic injection duration by the control unit, then we need to go for some correction over the first step, that is basic injection duration. Now, let me tell you why do we need to have this particular step, because in the beginning we had mentioned that basic injection duration calculation is reliant on a few sensors or input sensors, and those input sensors are engine speed sensor, airflow meter sensor, and manifold air pressure absolute pressure sensor. Now, question is, there are many other sensors which are responsible to give some input to the ECU, and those sensors are engine coolant temperature sensor, intake air temperature sensor, exhaust gas. So, the sensor which is responsible to sense the presence of oxygen in the exhaust gas. So, all these sensors can give some input to the ECU, and then ECU on receiving signals from these sensors corrects the basic injection duration time, so as to comply with the exact requirement for the engine. So, basically you know that basic injection duration is calculated or determined. Now, this basic injection duration calculation should be corrected so as to meet the actual requirement, and that is why the second step is necessary. Okay. So, this particular step, as I told you that basic injection duration is calculated using the lookup table that we have discussed a few minutes back. So, if I write here basic injection duration is calculated by using the lookup table. Which is already built in. Okay. Now, the second step, so that is already there. So, the second step that is the correction or introduction of correction factor, calculation of correction factor or correction over the first step. So, the second step is involved with the correction over the first step, right. So, to do these corrections, essentially as I said you, basic injection duration is calculated, that is fine, using the lookup table. Now, basic injection duration may not be the actual duration that is needed for the engine. So, to run the engine, if we need to run the engine always at the best efficiency, and if we need to ensure that the emission level should be under control or emission level should be reduced. So, always we need to have some correction over the basic injection duration, and those corrections are again reliant on the signals from a few input sensors, and those input sensors are, so input sensors are used for the corrections or correction of basic injection duration. Okay. And if we now mark this particular line, that we need to rely on a few input sensors essentially to correct the basic injection duration, and those input sensors are number one is engine water temperature sensor, to be precise I should write in a more generalized form, that is engine coolant temperature sensor. B is, that is throttle position sensor. C is intake air temperature sensor, and D is exhaust gas oxygen sensor. So, all these sensors are again responsible very much to gives some input to the control unit essentially to correct the basic injection duration so as to allow injector to operate properly, right. Now, let us discuss one by one by how really all these sensors can correct the basic injection duration. So, let us now consider some of these correction factors in some detail. So, let me tell you one thing, if we go to the next slide, if the engine coolant temperature or the intake air temperature increases or move from cold to warm, then certainly you can understand if intake air temperature increases or engine coolant or engine water temperature increases, that is obvious that I mean the fuel injection duration should be reduced, right, because we have no need to supply additional amount of fuel to accommodate the effect that may arise due to reduction in engine water temperature or engine coolant temperature as well as temperature of incoming air. Similarly, you know that if engine needs to open throttle or if the engine needs to have wide open throttle because of sudden requirement of engine load, then immediately the or momentarily frequency of the injection pulse should be increased momentarily, otherwise it is very difficult. So, if a particular engine needs to produce more load, more power, throttle should be wide open, that means more amount of air should be drawn into the engine cylinder. To burn that additional amount of air, we need to supply additional amount of fuel, that is what you have learned. Now, if we need to supply more amount of fuel, injection duration should be even more or longer, and that is essentially sensed by the throttle opening sensor. Next is exhaust gas oxygen sensor. So, exhaust gas oxygen sensor, what does it mean? I mean if the sensor which is placed on the exhaust manifold essentially to sense the presence of oxygen in the exhaust gas or exhaust gases, certain amount of oxygen is there in the exhaust gases, it means that the air that was there in that air that was drawn into the engine cylinder is still remaining unburnt. So, the total amount of air was not or has not been used by the fuel that was introduced in the engine cylinder for its burning. So, it is incomplete combustion, burning is not proper. So, that means again some corrections are needed to accommodate that particular aspect. So, all these sensors are responsible to correct the basic injection duration, that you can understand. As I said you that if exhaust gas oxygen sensor, that means the sensor which is used to sense the presence of oxygen in the exhaust gases can sense some oxygen, and if that particular level becomes beyond the threshold value, then immediately that injection has to swing between injection or injector or injection period swings back and forth between longer and shorter duration, essentially to adjust with the required or the allowed oxygen level in the exhaust gases. So, now I will discuss one by one correction for intake air temperature. The first one is correction for intake air temperature. Okay. Let me tell you one thing, why do we need to correct this? I mean why do we need to take this particular sensor or take this particular temperature, that is intake air temperature, to correct the injection duration. So, you know that depending on the temperature of the ambient air, the density of the air will change, which in turn will change the mass or volume of air to be drawn into the engine cylinder. So, we all know that if the air is cold, it will be more dense, right. So, that means depending on the ambient temperature, some corrections are needed for the injectors to supply required quantity of fuel so as to have or so as to maintain close to the stoichiometric air fuel ratio for its burning, okay, for the burning of the fuel. So, or for efficient combustion. So, the colder the air, the denser it becomes, that you all know. Now, if for this reason, so the density, if I write the density of air changes with temperature, and if it changes, so this correction factor, and for this reason, right, a correction factor or correction coefficient is used, correction coefficient is used for considering changes in air temperature. Essentially, you can understand that if air temperature changes, the volume of air or mass of air to be drawn into the engine cylinder will change, but if we need to have proper combustion, so adequate amount of fuel should be supplied. If we need to supply adequate amount of fuel for that particular mass of fuel or particular mass of air that is drawn into the engine cylinder during intake stroke, this injection duration time should be corrected, right. So, that is what it is. So, if we try to discuss this part with some graphical or coefficient graph. So, let me draw the graph. If we use correction coefficient, beta, correction factor or correction coefficient beta, I will be using suffix something to indicate whether that correction coefficient is for correction coefficient for air temperature or correction coefficient for coolant temperature, correction coefficient for exhaust gas oxygen, all these things. So, we are discussing now correction coefficient for intake air temperature. So, beta intake air temperature IAT. So, if I write here beta IAT, then the this is the variation and this is inlet air temperature, that is IAT. So, the reference temperature, the correction factor is unity or 1 when this is 25 degrees Celsius. So, this is 1. Now, if the intake air temperature is less than 25 degrees Celsius, right. So, as I said you that that if the colder the air temperature, that denser it becomes. So, if the correction temperature is less than 25 degrees, say for here, then you can see, say for example, this becomes 1.1, right, or it may so happen that the inlet air temperature is greater than 25 degrees Celsius, then it may be like this. So, this is 0.9. So, depending on the inlet air temperature, we can see that beta IAT, that is correction coefficient for inlet air temperature, changes from the reference point. So, this is the reference point. What does it mean? That means injection duration has to reduce by 10% if temperature increases beyond 25 degrees Celsius. Injection duration should be increased by 10%, that is 1.1, if the intake air temperature falls below 25 degree Celsius. So, that is what it is, and that correction or adjustments should be taken care by the control unit, as I said you, so as to allow injector to supply required or adequate amount of fuel as needed by the engine. Okay. If we go to the next one, that is correction for coolant temperature. So, that is engine water temperature, engine coolant temperature. Again, if I draw the coefficient graph. So, this is coolant temperature. So, this is coolant temperature or CT, and this is beta CT. So, correction coefficient or correction factor for coolant temperature, and the reference value is, if I draw, the reference value is 1 when this is 70 degrees Celsius. So, this is 1. Now, the coolant temperature will certainly be higher. So, engine water temperature, engine coolant temperature. So, if engine coolant temperature increases beyond 70 degrees Celsius, certainly the coefficient this. So, this is coolant temperature. I mean 70 degrees Celsius is a coolant temperature, that is engine water temperature. So, it is not possible or it is not allowed to have boiling of water in the cooling water jacket. So, essentially if the coolant temperature is less than 70 degree, right. So, below the reference temperature, if I try to draw here, then injection duration is increased. Right. Say it is, if it is say 1.2. So, if the coolant temperature is below the reference temperature, so this point is the reference point, right. So, when engine is cold, certainly coolant temperature will be less. So, when engine is cold, right, then fuel vaporization is relatively poor until intake manifold, until warms up, and this particular problem is known as that if the engine is cold, then fuel evaporation is relatively poor until intake manifold is warms up, and this is called lean drivability. This particular problem is known as lean drivability. So, lean drivability problem is associated with this, that means if engine is cold. So, if the engine coolant temperature is less than 70 degree, that means engine is cold, and in such a case, in such a condition, we need this correction, that if it is a case, then maybe we have to increase 20% injection duration depending upon the requirement. An extremely cold condition, it may require that the we need double, that is 100% even increase in the fuel injection period. So, that is based on the engine requirement. So, what we can understand, that depending on the engine temperature, which can be better understood by the coolant engine coolant temperature sensor, if engine is cold, fuel evaporization would be affected, and it will lead to a problem that is known as lean drivability. And to circumvent or to alleviate this particular problem, what we need to do? We need to take into account this particular correction so as to increase the fuel injection period or duration. And then next one is power enrichment correction. So, this is again for this correction engine needs to rely on, or not only engine, the electronic control unit needs to rely on MAP, that is manifold absolute pressure sensor. Let me go back to previous two slide. Correction for coolant temperature, if we write here, so this is for this correction ECU is dependent on or reliant on engine coolant temperature sensor. If we go to the next slide or previous slide again, so correction for intake air temperature, if we write here, so again ECU should rely on some sensor for this correction, and that sensor is intake manifold air temperature sensor. So, we can understand that we have discussed that second step is reliant on a few input sensors. The first one is reliant on intake manifold air temperature sensor, second one is on engine coolant temperature sensor, third one that we are going to discuss is reliant on manifold absolute pressure sensor. So, let me write here a few points, or if I can draw the graph. So, again if we try to draw the curve, that is correction coefficient for power enrichment correction. So, this is intake air volume or throttle angle. Okay. So, here it is called beta power enrichment, beta PE. So, this PE is this P stands for power enrichment. Okay. So, this is something like this. If we draw the curve, so this is 1, and what we can see, so this is the for this is the reference 1, correction factor 1, that means it is no further correction is needed. So, it is fine. If the intake air volume or throttle opening angle is becoming more, so as to adjust with the power enrichment or so as to enrich the power, certainly the coefficient should increase, that you can see from the curve, right. So, in this range no correction is needed, no correction is needed for this range of intake air volume and throttle angle. So, now let me tell you one thing, why do we need to have this? All of a sudden if engine needs to deliver moderate to heavy loads, then if we demand more power from the engine, certainly injection duration should be higher, right. So, to increase the power or load that would be produced by the engine, we need to have or we need to open the throttle opening, so as to allow more amount of air into the engine. Now, to have that much power, we need to supply adequate amount of fuel to maintain stoichiometric air fuel ratio. So, if the volume of air is increased or volume of air drawn into the cylinder is becoming more, then certainly we need to, or the injectors or the control unit should give some feedback to the injector to supply more amount of fuel, so as to maintain stoichiometric air fuel ratio. And that is why this particular correction factor should be taken into account if the throttle opening angle is becoming or increases beyond this value, right. So, if for this range correction is needed, right. So, this is correction is needed, that you can understand. So, this is essentially power enrichment. So, power enrichment is very important. So, since electronic control unit should be flexible enough to meet the demand, certainly all these facilities should be built in, so as to allow engine to meet the requirement, to meet the demand. So, now if we go to the last one, that is known as battery voltage correction. So, the final one is the battery voltage correction. So, this is called battery voltage correction. So, why this is important, that battery voltage correction? Let me tell you one thing, for any fuel injectors, this needle movement is again controlled by the magnetic plunger, and we need to know that movement of the magnetic plunger is again controlled by some battery. So, we need to allow that magnetic plunger is essentially a core which is with having with copper or copper wire is wound over the core, and then we need to allow current to flow through the copper wire. So, let me tell you one thing, magnetic plunger is fabricated using any particular core of iron core, and iron core is wound with copper wire, and if we need to supply current through the copper wire, and then we can have magnetic field. And so, basically that current is allowed to flow through the copper wire using a battery. Now, if the battery voltage drops, the amount of current that will flow through the wire will also reduce. So, then the magnetic actuation should be affected. So, the movement of the magnetic plunger should be affected. If the movement of the magnetic plunger is getting affected, certainly the movement of the needle should be affected. So, if the movement of the needle is affected, so fuel injection should be affected. So, in a way battery voltage correction is needed, so as to adjust the delay associated with all these issues. So, just I will write one or two points here, that one is called operational delay. Okay. So, first of all, if I write here, if the voltage of the battery varies, it is likely that the time taken to open the injectors will vary. That is what I was telling, that the injector is controlled by the magnetic plunger, and the movement of the magnetic plunger is again controlled by the current that will come from the battery. So, this battery voltage drops, then the amount of current that will flow through the magnetic coil will reduce, which in turn will reduce the injector closing opening part. So, this is important. Now, the question is, electronic control unit will give some signal to the driver circuit of the injector, and receiving that signal, driver circuit again will give some signal to the injector. So, there is a delay between these two time. So, let me tell you one thing, electronic control unit will give some signal to the battery driver circuit, and that driver circuit again receiving some signal from ECU will give some signal to the injector. So, there is a time lag between these two, and this is called operational delay. So, the time lag between time needed for ECU to give a signal to the driver circuit and time needed for the signal that will come from driver circuit to the injectors. So, there is a lag, and this lag is called operational delay. So, essentially some correction should be taken by the battery voltage so as to take this particular correction. Okay. So, important part is, if I write in the next slide that the delay, so operational delay, just I will be writing operational delay. What is this? As I told you, so delay between the time the ECU sends the injection signal to the driver circuit and the actual opening of the injector. Okay. This is the operational delay. So, this delay changes with the strength of the magnetic field. So, now this delay will be again, this delay changes with the strength of the magnetic field around the injector coil. Okay. So, the delay, then so delay is getting compounded. So, this delay will increase if battery voltage drops. So, this delay increases as the battery voltage drops. Right. So, to determine the fuel injection duration or final fuel injection duration, ECU corrects this ECU corrects for injector opening delay by using the battery voltage correction factor. Or coefficient. So, that is what you can understand. So, the operation delay should be again compounded because of the drop in battery voltage, because that is also related to magnetic field strength that I told you. Magnetic plunger is responsible for the movement of the needle. Now, if the current passing through the magnetic coil is reduced, magnetic field will reduce, which in turn will alter the needle movement. So, the operational delay is compounded, and so this delay changes with the strength of the magnetic field around the injector coil, and hence to correct this ECU needs some voltage correction factor, and that is what it is. Okay. So, now I write a few points before I stop my discussion today, that so if I write here, in case of a low amount fuel injection, a non-flammable mixture is prepared, right. So, therefore, minimum fuel injection limit or time limit has to be defined to prevent formation of unbound hydrocarbons, right. In the exhaust gases. Okay. So, why? So, let me tell you one thing, why do we need to have some corrections over the first step, because if we do not do all these corrections, certainly if the fuel injection time is not proper, so if the amount of fuel injection is low, then what will happen, that a non-flammable mixture is prepared, right. So, basically it is not stoichiometric. So, what will happen, the minimum fuel injection time limit has to be defined to prepare formation of unbound hydrocarbons in the exhaust gas. So, essentially this part you know very well, that will increase the emission level. So, question is, if the requirement of fuel by the engine for a particular condition is less, ECU should be able to supply metered quantity of fuel so as to prevent this undesirable phenomenon. So, that minimum time limit has to be defined by the ECU, so that injector can only supply low amount of fuel if situation demands for. And the last important point that I would like to discuss, that whatever we have discussed today is essentially when engine is under operation, but when engine is during engine start, the calculation of fuel injection period is separate, and it is not dependent on whatever we have discussed in today's class. So, to summarize, today we have discussed about injection time duration calculation steps. We have identified two different steps, we have discussed these two different steps in detail, and then we had seen that proper injection time duration is needed essentially to maximize the engine efficiency and to reduce emission level. With this I stop here today, and we shall continue our discussion in the next class. Thank you.